Actually, you have taken the fifth place, but you have done 9 correct and only 1 incorrect. But the time taken for you will be somewhat high. That's why you are in the fifth place, even though you have done only 1 mistake. So people have taken, I think, by conducting this type of quiz. Today you don't have a quiz, okay? So actually, you people have some understand some concepts, and I have put your assignment. Have you all checked the assignment? Tyagi, register number 48.
Yes, ma'am. I checked the
Yeah, yeah. Have
assignment.
you seen the assignment?
Yes, ma'am. Ninth we have to submit. Ma'am. I have to see. Hmm.
You didn't see. Actually, I gave. I told you while we are conducting assignment. Um, you all understand assignment 15 marks, na? 5 MCQ or fill in the blanks. I have given 5 fill in the blanks, 5 short question. Each question 1 mark, and 1 long question. So totally you have a 3 divisions, and this is a common method we were following this time to give a mark universally for all the subjects. So you all understand, giving assignment and all, you are supposed to upload your assignment through LMS. So I have uploaded the assignment on 31st itself. So you people attend the assignment, and I have repeatedly told that assignment should be the unique, don't copy from others. If your assignment is copied one, even though you are the source one and you help your friend, for both of them I will reduce the mark. So don't share the assignment to anyone, because we people were correcting 100 assignments now. Don't think that we won't give the mark as it is. While we are seeing itself, we can understand whether it's a copied one or unique one. Even though it's a wrong, try to do your by yourself. Are you clear? um, have you seen the assignment, Ma? I have given assignment for you people. Right.
Yes, ma'am.
Yeah, I think assignment. Yeah, now we don't have that. Once again. Mm. So people see your assignments. So we gave, actually I will share the assignment for you. Why I am, most of them don't know the importance of the assignment. That's why I am sharing the assignment today for your purpose. Mhm. Okay, I think the particular is not opening. Now, can you able to see this assignment? See, listen, I gave 5 fill in the blanks. Okay, and 5 short questions and 1 long question. And this is the assignment I have uploaded in the um, LMS. People, please try to understand.
Ma'am, your screen.
You can't able to see the screen, Amma.
No, ma'am.
I don't know what's the problem on showing the assignment. Mm, I don't know, the particular assignment is not opening. Uh, yeah. People can able to see it more now? Is it visible for you?
Yes, ma'am.
Yeah.
Yes,
I
ma'am.
gave, okay, ma. I gave 5 fill in the blanks. I think you can able to download the assignment. So you copy it and write the questions. Please, you must write in your handwritten, ma. Don't upload any typed material. Okay. Can you understand or not? Fill in the blanks. You just write 1, 2, 3, 4, 5. Just write the answers alone. And for short questions, mention the question number and write the answers alone, and the long question. So I think the maximum size of the paper you can upload will be 32 MB only. So while you are uploading, you compress it and upload. Can you understand? That file can be acceptable in any form, whether it may be in a Word or PDF, or it is in a compressed one, whatever may be, it can be acceptable one. So people, please kindly submit the assignments. It's very very important one for your assessment marks. So give the importance, and after ninth automatically it will be disabled. Don't think that you can upload it at last, because today the date is second and you are supposed to upload for 4 subjects, not only for my subject. You are supposed to upload for 4 subjects. So please give the precious time of yours and complete it and upload it. You can start uploading from today onwards, because on the day one itself we have allowed you to upload. If any students have any problem in uploading, kindly message me. Are you clear? So people start uploading, because it's very very important for your um, calculation of a. So if you are missed to submit, automatically you can't able to upload after ninth. Can you understand or not? So we don't have a software facility to disable the date and all. Once if it crossed ninth, you can't able to upload it. So I'm repeatedly saying for your concern to submit the assignment. Okay. So Harshavardhan, you have raised your hand. Any doubt, Harshavardhan? We'll go on to the topic. Any doubt, Harshavardhan? Harshavardhan, register number 34. Yeah. No. Okay, okay. You people were playing by raising the hands. Okay. Now, instruction set, we have discussed all the 4 types: arithmetic, logical, data transfer, Boolean. So, arithmetic, uh, we have seen all: add, sub, multiplication, division, increment, decrement, and all. Logical, and or exclusive or operation, rotate operation, swap instructions we have seen. Data transfer, move instructions we have seen. And Boolean variable means it's a bit oriented instructions. So the last one today we are going to do will be program branching instructions. So I think it's very very important instructions, branching instructions. So people try to listen the branching instructions. Yeah, okay. So branching, I told you, we have a want to change the sequence of the program. The branching instructions will be very helpful. So there are call instructions, jump instructions, return instructions are there. Okay. So jump, we have a 2 types: unconditional and conditional jump. So conditional, unconditional means na, unconditional na, if jump comes automatically, my program will goes to the particular location without checking any condition. Conditional jump na, it will check the condition. What is the condition here? It will check na, it will check the conditions of flags. So it will check the carry flag, or it will check the zero flag, or sometime it will check the bit also. So here the conditional jump means it will check the status of the flag as well as status of the bit also. So you understand that if I want to change the sequence of the program, these are the jump instructions we are going to see. Okay, now we will see first JMP. JMP stands for what? Jump. I think this syntax already we have studied in the 8085. So the same thing, but here we have a some instruction, unique instruction, which is compare, decrement. Along with that, we have jump instructions. So in the jump instruction, we have a two jumps: unconditional and conditional jumps are there. So here, while we are checking unconditional, Final is and the last. Okay. Okay. Now, so we have a unconditional conditional jump. First, we will discuss about unconditional. It won't check any condition. It will automatically go to the particular location without checking any condition. So we have a three type of jump. JMP is always stands for jump, but A jump, L jump, S jump. Actually, what is the difference between A jump, L jump, S jump? Now, this will go to the particular location. S stands for, S jump means short jump. Are you clear? Very, you understand? S stands for short jump. L stands for long jump. And A jazz stands for absolute jump. You may ask, what is short jump, long jump, absolute jump? Now, short jump, we all have a different coding memory here. We have an internal memory, external memory, and all. So short jump means it will check only 256 bytes. That means what? 00 to FF location only it will check. So it will check only the internal RAM memory locations. That is short jump. Okay. Long jump. Long jump means it will check 64 KB memory. That means 0000 to FFF. So that is 64 KB. A jump. Absolute jump. Actually, absolute jump means it will check only 2K. So 2 kilobytes memory only it will check. So that's why in the memory, actually, to avoid the memory, we are having this kind of jump. So whether I want to check using S jump, why I have to check the entire memory location? Only I have to check only 256 bytes memory location. L jump means obviously I have to go to the external memory and I have to search the particular page. A jump means my program have written in the particular page. I will show you how it is page. 2K or 2K only maximum it will check. So it will check only 2 kilobytes memory. 2096 location only it will check. Okay. So next one is conditional branch. So conditional branch, I told you jump on carry, jump on no carry. Okay. So here you have a CJNE. Actually, here we don't have a separate compare instruction. So compare and jump are conjuncted together. So we will discuss the conditional branch separately. Now we will focus on unconditional branch. So I have given this images. People, please have a look on this. Ljump. Ljump means I told you how many byte ma? 64 KB. So my memory will start from 0000 to FFFF. So 64 KB it will jump. A means it will always checks for 2 KB only. So if I am checking this, whether it is checking upper 2K, not checking upper 2K, na, it will check only lower 2K. If it is in the low upper 2K, it won't check the lower 2K. Can you understand? So 2 kilobytes memory only A jump will check. Okay, S jump means I told you 256 locations. So 00 to FF. Actually, 0 to FF means 256 memory location. I told you in terms of location. So minus whether it is assigned na minus 128 to plus 128. Both are 256 bytes only. Okay, 0 to 256 we can say, or minus 128 to plus 128. Both are same only. Okay. Now, so the branch instruction, which is given briefly, the 8051 4 divides a unconditional jump. So first one is what ma? Short jump. Short jump means the location they have specified 00 to FF. That is 256 locations it will check. Okay, it is a 2 byte instruction only because it will take check only 0 to FF. This is 1 byte and the opcode for S jump is 1 byte. So only 2 bytes 2 byte instruction it is. So don't think jump, all the jump instructions are always 3 byte instruction. Normally we will say what is 1 byte, 2 byte, 3 byte ma? 1 byte means it will occupy single memory. 2 byte means it will occupies 2 memory locations. 3 byte na it will consecutively occupies 3 memory locations. So short jump means it will occupies only two memory locations. That means one memory for the memory location and another for opcode. Okay. L jump. L jump means it use, I told you, it use 16-bit address. 64 KB memory it will check. So it will check the entire 64 KB memory. So it's a 3 byte instruction. Then absolute jump. Okay. Absolute jump means I told you it's verify only single page. Actually here we have a page structure. Page 0, page 1, page 2, page 3. How we were in the book, how we were identifying the chapters now. If there are 20 chapters are there, if the particular copy is topic is in the 5th chapter now, we won't check from chapter 1 to chapter 20. We will go to the chapter 5 and we will check the particular chapter alone. Similarly, a jump means it will check only the single page only. What is the single page capacity? 2 kilobytes only. So it will check only 2 kilobytes. Actually, it will use the 11-bit address. I will tell you how it will check the 11-bit address. And this is also 2-byte instruction. Okay. Now you see, this is the page structure. I told you now 2 KB. So you see that page 00 means which location it will check ma 0000 to 0A7FF. I think you see this, you can understand how we can 2K, 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 2K. So I think how many 2Ks are there ma? Nearly when you allocated that 32 pages are there. So 32 pages na 30 each page. What is the capacity? 2 kilobits. So 32 into 2 KB. How many capacity ma? 64 KB we will attain. So the A jump is the jump instruction which will have a page like structure. It will always check the particular page. What is the capacity of each page? 2 KB. So it is easy for us to go and fetch the data. So you understand that A jump, L jump, S jump. All the three are unconditional branch instruction. S jump will always focus on 256 locations, 00 to FF. L jump is for 64 KB locations. So it will check the 16-bit address. And A jump, absolute jump, it have a page structure. It will always check the particular page. So each page having the capacity of 2 kilobytes. Are you clear? Okay, you just have understand. I told you it's a 11-bit address and all. Now how it will take the opcode and how it will take the actually while we are seeing it will get only A0 to A10. Actually 11-bit only. So one is for opcode. Can you understand or not? A8, A9, A10 which will taken from the program counter. Okay, so from that it will take the first bit. So obviously it having the program counter lower order byte completely, and then A10, A9, A8, that is opcode. Opcode in sense means they are saying it's a page structure. Page structure means what ma? 0001. I told you now. Once again. 0001, 02, 03 we were having na, that particular will comes to this. So obviously it having from A0 to A10 only. So the locations it will take only 11 bit of address only. So 11 bit na, the target address must be within the 2K bytes of memory location. So the opcode will be actually depending upon the page, it will may vary. Okay, I told you how many pages are there ma? 32 pages are there. What is the each page capacity? 2 kilobyte capacity. So from that only it will identify the address of the A jump. Okay. Then L jump, the same thing, unconditional jump. We have a 16-bit address. Okay. S jump is nothing but again the same thing only. Okay. So L jump, S jump, A jump will be there, but jump is also there. Jump means here how the jump will accept now. We all know at means what? Indirect addressing mode. So what this particular instruction will do now, how it will calculate the address now, it will find the sum of accumulator plus data pointer. That particular address will be identified and indirectly it will go to the address and it will check. So jump, we have a 4 unconditional jump instruction. L jump, S jump, A jump, and jump is there. But normally this instruction is rarely only we will use. Normally we will frequently use the 3 jump only. This is the way to calculate the address of the jump instruction. Okay. Now we are going into the conditional jump instructions. Okay. Register number 61. Pandya. Are you here, ma? Pandya. Pandya.
Ma'am, yes, ma'am.
Are you listening?
Yes, ma'am.
Okay, ma. So now we are going into conditional bunch jump. Okay, are you clear? In the conditional jump, we have some conditions. So we will see one by one with examples. The first condition is J is Z. Pandya, what is J is Z, ma?
Jump 0, ma'am.
Jump 0. So if my accumulator is 0 means automatically this particular instruction will work. All you always understand, jump 0 means it will always check the primary register. What is my primary register? Accumulator. JN is it? What is JN is it, ma?
Jump no 0.
And jump on no 0. So jump on no 0 means it will check whether accumulator is not equal to 0 means this particular instruction is valid. Okay, mute your mic, Pandera. The next
Okay.
one is jump on carry, jump on no carry. So what is jump on carry? If the carry flag is set, automatically my instruction will go to jump on carry. Jump on no carry na, if carry flag is cleared, automatically my particular program will transfer to particular location. So this is two conditions. We will see how it is working. I think I have put with one small example. J is z, J and z. Jump if accumulator is 0, jump if accumulator is not 0. So I am writing one program, move a comma r5. Okay, jump on 0 na, I have to exit from the loop. My what is my have loaded with a move r5. R5 is 55. So what is my accumulator value ma now? My accumulator value is sorry. So every time I have to check my R5 value. When my R5 is 0 only, at that time only my accumulator is 0. So what I have written, move a comma R5, I have to check whether my accumulator is 0. If my condition is true only, it will go to the next. Next means what? The particular memory location. Otherwise, this loop will be keep on executing. Okay. The next one is JNZ. JNZ means what ma? Jump if accumulator is not 0. People understand first that I'm loading my register with one accumulator value. Every time I'm checking my conditions. While I'm checking the condition, I have to check whether my accumulator is not equal to 0. Whenever my accumulator is not equal to 0, it will go to the particular address. Otherwise, what happen? It will go to that particular address. So here you understand J is na, when accumulator is 0 only, if the condition is true only, it will exit the loop. Here, if the accumulator is not equal to 0 only, it will exit the true. So J is it, J and Z. You understand this J is it and J and Z. Always examine the accumulator content. Are you clear? Okay. Now I have written for J and C. I have told you the two instruction is jump on carry, jump on no carry. Okay. So the same thing is move a comma hash. Hash means what? Immediate data. So I am loading my accumulator with FF. Now I am adding a comma 01. If I am adding FF plus 01, automatically what happened? Carry will set. So when the if carry is not set, jump on no carry, na, it will go to the particular location. Or else what it will do? Increment the R5 register. So always understand, jump if jump on no carry. All you understand, jump on carry. Carry flag is set. Jump on no carry means of automatically what meant? Carry flag is cleared only. Automatically it will go. So jump on carry means carry flag is set. Jump on no carry. Now carry flag is not set or carry flag is cleared. Okay. So I have given one example program here. You people can understand this. Um, Akashing. Akashing, are you here, ma?
Yes, ma'am.
Yeah, yeah. What is the first instruction, ma? What is the first instruction? Can you able to see the screen? I think
Yeah,
Akash.
ma'am.
Yeah, tell me. What is the
Ma'am,
instruction? Move a comma.
move a hash 0.
Okay. Listen, Akash. What is the program? We are
Find the
going.
sum of the values. Yeah, ma'am.
Okay. I have to find the sum of 79 plus F5 plus E2. That I have to do the programming. Okay. My lower order byte should be in R not register. Higher order byte should be in R5 register. Okay. Move
Okay.
a comma hash 0 means what is my accumulator value? I have written the instruction
Ma'am,
also. Uh,
yeah, ma'am.
what is my
A
accumulator?
bracket A is equal to 0, ma'am.
A comma hash means what? What is hash represent? What? Which type of addressing mode? Hash always holds what,
Ma'am,
ma?
bracket
Here I am saying hash. Hash means how many time I am saying?
bracket.
No, hash means immediately I have to move the data to the accumulator. If I put accumulator hash 0 means
Oh,
my accumulator is 0. Are you clear? Okay. Now,
yes,
next
ma'am.
instruction. What is the next instruction?
Move R5, comma A.
That means I have to move my
A, A register to R5.
yeah. You always understand what is the syntax for move. Destination comma source. So accumulator to R5. Okay. What is the next instruction? What is the next instruction?
Add A, comma hash 79H.
Yeah, 79. You all know this hexadecimal number. A comma. What is my A value? Previously
Yes, ma'am.
0. And now what is the value I have to add?
0.
I add A comma hash 79 means what? 0 plus 79.
79H.
Are you clear? So I have to add my accumulator with 79. Are you clear? So 0 plus 79. Whether carry will generate it or not, ma? Carry will generate or not,
No,
Akash?
ma'am.
No, very good. So the carry will not come. So automatically jump on no carry. Now I have to go to
Jump on.
this location. If carry comes, INC. INC means what? INC stands for what? INC stands for what, Akash?
Increment, ma'am.
Increment.
Ma'am, increment, ma'am.
Increment the register. Okay. Now, yeah, mute your mic, Akash. Actually, Akash, listen the class. Some of the people are not listening, and some of them are listening very well. Actually, you in the quiz, I have taken top 5. I have to take the least 5 always next class onwards. You people are all. Some of them were listening, some of them were not listening. Balaji, 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 where switch on his class and
Ma'am,
given summary. You are
ma'am,
there,
ma'am.
man. Okay, okay. Add a comma hash 0 f5. That means what is my accumulator value after adding?
A is equal to 0 plus 79 H.
Yeah, actually, accumulator contains 79. Now I
Yes,
have to
ma'am.
add 79 plus f5. So
F5.
79 plus f5. Actually, what is my answer now? 6e, but
6C.
carry will be set right. Okay. So carry is generated. Jump on no carry. This condition is fails. Am I correct or not?
Yes, ma'am.
Because carry flag is set. So now what I have to do? I have to increment which register?
R5, ma'am.
R5. So I have incremented R5. Okay. Yeah, mute your mic. Then next one is add a comma hash 0e2. 0e2 now actually accumulator contains what, 6e. 6e plus the last number is what? E2. So 6e plus E2 I am adding. While adding 6e plus E2, you all know accumulator will store only 8-bit data 50, and automatically my carry is generated. So if carry is generated, automatically this condition becomes fails. So it will go to the next location, INC R5. Already R5 is 1, and once again my R5 has to increment it. So R5 will become 2. Now move A comma R0. A comma R0, what is the value? A value should move to R0. So R0 is 50 and R5 is 2. So if I add F9 plus F5 plus E2, what is my answer? 250 is my answer. So 2 is higher order byte is stored in R5 register and lower order byte is stored in R0 register. Are you clear, ma? So this is very simple program to understand how my jump on no carry instruction is working. So I have added 3 thing by adding every time I am checking my carry flag. If carry flag is not set, automatically it will go to the particular location, or else what I have to do? I have to increment the R5 register. Okay. So if carry flag is set means this conditions will become false and it will go to the next location. In this condition, the condition is true. So it is moving to this location. But here the carry flag is set. So this condition become false. So false means it will go to the next location. In the next location, it is indicating I have to increment my R5 register. Okay. So we have seen 5 conditional jumping instruction. One is first we have seen jump on 0, jump on no zero. It's a one conditional. And the next condition is jump on carry, jump on no carry. Okay. The third condition is JB, JNB. Actually, yesterday we have discussed same thing only. If the bit is set, automatically jump on bit will work. J and B, jump on no bit. That means what? If bit is not. So you understand this particular instruction, it always work for not all the things. So whenever my register is addressable, you understand, accumulator we can check. We can check with the port. Port means what? Accumulator, port 0, port 1, port 2, port 3, I can check. I can check the carry flag also. Okay. That is, carry flag means it will consider the bit of the carry. Okay. So jump on bit, jump on no bit. Okay. So the two instructions are there. So I can check with accumulator and ports. Next, the instruction is jump. If bit is set, then clear the bit. I have to jump. If the bit is set, I have to, for example, accumulator 1.2, I have connected one LED. Okay, can you understand or not? So I have to check. Okay, now the LED is automatically it is glowing now. I have to glow my LED, and after some time I have to clear the bit also. So jump on bit, and then what happened? JBC means are jump if bit is set, and as well as clear the bit. Okay, so this is the next two instruction: jump on bit, jump on no bit, then jump if bit is set, then clear the bit. So the last one is compare and jump if not equal. See, understand this. This is the very, very important instruction. Here we don't have a separate compare instruction. Are you clear, ma? Here we don't. Previously in 8085, we will compare accumulator with register. So we will say carry flag set. Carry. Here we don't have a, such a compare instruction. Compare is always check along with the jump instruction. So CJNE, this is the instruction which is introduced in microcontroller. By connecting the compare and jump instruction, the total number of instruction get reduced. That is the one main advantage. So CJNE mean compare and jump if not equal. So you understand, compare and jump not equal. Can you understand or not? So I will compare my accumulator content with the direct memory address. I will compare my accumulator with the immediate data. I will compare my register with the immediate data. I will compare my indirect address with the immediate data. So compare and jump not equal means REL means what? It will go to the particular address, relative address. Are you clear? So CJNE. CJNE compare and jump if not equal. So when it will compare and jump if not equal, now compare the magnitude of the two operands and jump if they are not equal. For example, I have to compare my accumulator content and my data. If both are not equal, automatically it will jump to the particular location. So always remember, if both are not equal, can you understand? They have written very clearly. Compare the magnitude of the two operands. What are the operands? Accumulator and the data. I have to check the accumulator and the data. If both are not equal, I have to jump to the particular address. Are you clear? Okay. So they have given the same instruction only. I have given in elaborately. Okay, both are same only. Then, so we have seen compare with jump. Then next one is one popular instruction. Every time we will use this instruction in our program. Decrement and jump, we have conjunction. We have separate decrement instruction is also there. So every time what we will do, we will decrement and we will check for 0. So here we have DJNZ. DJNZ means decrement jump if not 0. So if the particular register is not 0, or if particular accumulator is not 0, or if particular direct memory address location, it will go to that particular data. Na? So decrement jump if not 0. Can you understand or not? So every time I have to decrement the first operator. For example, my RNS 5 means I have to decrement. 5 has decremented. Na? You all know decrement means what? It will decrement by 1. So 5 will become 4. So it won't jump to the location. Then next loop, 4 will decrement to 3. It won't jump. Then 3 will decrement to 2. It won't jump. Then 2 will decrement to 1. It won't jump. Then 1 will decrement to 0, 0. So decrement and jump if not 0 in sense means if the particular value is not 0, then automatically, can you understand or not? So the resulting value is not 0. It will go to the particular address. When it will exit the loop, ma? When it will exit the loop, when Rn is 0 only, it will exit the loop. Otherwise, it will keep on executing the loop. Decrement, jump if not 0. Are you clear? If Rn is 5, it will go to that loop, but that part loop is keep on executing. When it will exit from the loop, when 5 will become 4, then 4 will become 3, then 3 will become 2, then 2 will become 1, and 1 will become 0. At that only it will exit the loop. Otherwise, it will keep on executing the loop. Can you understand or not? So mainly this DJ and Z, we will use it in our subroutine instructions. Okay. So the same thing only. So I can, what is the maximum value I can load, ma? Rn means what? Rn is what, ma? 8-bit register. So Divagar, register number 28, Divagar.
Yes, ma'am.
What is the maximum 8-bit data, ma? What is the maximum 8-bit data? Hey, what, man? Drinking water and telling the difficult answer.
No, ma'am.
Then, what is the maximum 8-bit number I'm asking?
FFF.
FFF, very good. So the same thing is FFF now, the maximum value is FFF. So it will keep on decrementing and it will goes to the loop. So when FFF is 0 only, automatically it will exit the loop. Can you understand or not? So DNZ means decrement, jump if not 0. Are you clear? Okay. Mute your mic, Divagar. So I have written one simple program for you. Just to understand the program, people, please listen the program. Load the accumulator with 55. Okay, and complement the accumulator for 700 times. Okay, you understand this? Complementing its sense means you all know what is 55, ma? What is the value for 5, ma? 0 1 0 1. Am I correct or not? 0 1 0 1 0 1 0 1. If I complemented, what happened? 1 0 1 0 1 0 1 0. Is clear? Actually, we have an annotation option. If I gave away get the annotation option, you people are scribbling every time. We have to clear it. That's why we removed the annotation. You are in. So others I can write it and show. So a equal to 55. Are you clear? If I am complementing, na, my 55 will complement and my value will become AA. So 1 will become 0, 0 will become 1. It's just like a on and off, on and off, on and off. Just like a toggling condition, we can say. How many times we have to toggle? 700 times. You just listen how we were writing the program. Okay. So you have to understand we have a inner loop, outer loop, two loops are there. I will directly go on to the program. Move a comma hash 55. So what I am doing? Hash means what, ma? Immediate data. So what is my a value? A is equal to 55. Okay. Now move R3 hash comma 10. You have to understand that I am doing my accumulator for 700 times. So what happened means one complete time it will execute 70. Can you understand or not? R2 has 70. Na? This loop will keep on executing for 70. Then once again it will execute and it will go on. So 70 into 10 means what? 700 times. So inner loop value into outer loop value. So inner loop will executed for 70 times. Once it's completed 70 times, then it will go and it will decrement the R3 value. First you assume my R3 is what, ma? 10. Okay, move R2 comma hash 70. So what is my value of R2? 70. CPL means what? Complement. Okay, complement the accumulator content. Okay, and DJNZ. DJ, I told you, D means what? Decrement, jump if not 0. So what is my accumulator value? 70. Actually, DJNZ R2 means 70 will become what, ma? 69. Again means it will complement. Okay, then after this, once again what happened? R2 69 will become 68, then 67, 66, 65. It will keep on decrementing till 0 0. So once R2 becomes 0, it will exit the loop. Are you clear? That's why I have given that example. Once till R2 70, 69, 68, 67, till it will execute. When R2 becomes 0 0, it will come to this. Then DJNZ R3. Actually, what is R3 value? My 10. So now 10 will become 9. So 9 next means again it will go to the inner loop. So after completing the inner loop, once again it will come and it will execute the outer loop. So now 9 will become 8, then 8 will become 7, 6, 5, 4, 3, 2, 1. So 70 into 10, 700 times it will keep on toggling the values. Are you clear? Okay. So I think branching instructions. Branching instructions. Now I will go. Okay. These are the instructions we have seen. Okay. Parameshwari. Parameshwari.
Hello, ma'am.
Yeah. Tell me, ma. What are the thing we have discussed in conditional branch? JC means what?
Jump carry, ma'am.
Jump carry. Very good. JNC.
Jump no carry.
Jump on, no carry. Very good. Then CJNE.
Compare and jump if not equal.
If not equal. Very good. Then J is it?
Jump 0, ma'am. Jump on
Jump
0.
on 0. JN is it?
Jump on no 0, ma'am.
Jump on no 0. JB.
Jump on bit.
Jump if bit is set. Okay. JNB.
Jump no bit, ma'am.
Jump if bit is not set. Okay. DJN is it?
Decrement and jump if not 0.
Very good. So you mute your mic, ma. So these are the conditional branch instruction. So you understand that unconditional and conditional branch we have discussed. Are you clear, ma? We have completed the entire jump instruction. So jump instructions now we have seen A jump, L jump, S jump, and jump is also there. JMP at A plus DPTR we have seen, but rarely we will use. But normally these three unconditional branch instructions are very popular, and these are the conditional. So here conditional branch now it is not similar to 8085. 8085 we will check always the flag conditions. Here it checks only two flags: jump on carry, jump on 0. Then other and all it will check the bit. Then compare and jump is also there, and decrement and jump is also there. DJN is the very popular instructions. We will keep on use it in our program. Are you clear? So jump instructions are all get over. Yes, clear? So all the jump instructions we have seen. Then the call instruction. Call, you always remember, call means if I want to call my main program to subroutine program, I will use call instructions. Are you clear, ma? In call, what is subroutine? Na? If my motor is rotating, stepper motor is rotating, it rotating at some speed and all, na, the speed will be decided by the subroutine program. Always remember the time delay will generated by the subroutine program. So there is no logic in the subroutine program. It will load one value in register, it will decrement the register. I told you while we are saying 8-bit data, what is the maximum data I can load? FF in registers. If I want to load my 16-bit data, na, I have to use DPTR. So I will load 4FFF. So it takes some more time. So the only thing is, or I can use inner loop, outer loop and all to increase my time delay. So if I want to increase the time delay, I have to increase the register value, loading my register value. Maximum 8-bit can load FF and 16-bit can load 4F. So what is the call instruction now? Main program to call the subprogram. Always remember what is the use of call? Main to subroutine. So if I want to return from subroutine to main, I have to use which instruction, ma? Return instruction. Are you clear? So call means main to subroutine. Return means what? Subroutine to main. Are you clear, ma? Okay. Actually, this is the time 10:20. Okay. So absolute call, L call is there. Okay, you will leave this. I think these are all okay. Absolute call, L call. Okay, I think you can understand what is absolute call, ma. It will call within 2K page, 2000 bytes only. L call means what? 64 kilobytes memory it will check, but it will check only 2 kilobytes of memory. That is the two difference. So we don't have a S call here. We have only absolute call and long call. Are you clear, ma? Absolute call. So call means what? Main to subroutine. Always remember, if I want to call my subroutine program or my time delay program, I will use my absolute. So here also the same thing. Absolute, what we learn in A jump, the same concept in absolute call only. It will call only the 2K page only. Okay. So L call means 16. We have to use 16 address. That is means what? 64 KB address I have to use. Okay. Then the another popular return instruction, RETI. Okay. RET means I told you I want to return from my subroutine to main program. I use RET. RETI means you have to understand that we have seen interrupt service routine. So if I want to interrupt, I want to return from any interrupt, I have to put RETI. So we have a two form of return instruction. So return from subroutine and return from that interrupt service address. Okay. So there is RET and RETI. Okay. So these are the entire branch instructions. We all know NOP is always stands for no operation, which is given there. So A call address. A call means what? Absolute call. It will check only 2K page. L call means what? Long subroutine call. It will check 64 KB. Return. RET na return from subroutine. RETI return from the interrupt service routine. Okay. A jump means absolute jump. It will check 2 KB. L jump means address 16-bit address. That is 64K. It will check. Okay. A jump, why is they are saying 11-bit address ma? It will check only 2 KB. 2 KB na 2000. So the maximum value will be only 11 address only will be there. Then yes jump. Yes jump means what ma? Only 256 bytes locations only. It will check. Short jump. Jump at A plus DPTR. I told you indirectly I can go to that particular memory location. Then jump on 0, jump on no 0. Similarly, compare and jump if not equal. Decrement and jump if not equal. Then no operation. Only one jump is missed. Which jump, ma'am? Jump on carry and jump on bit, because we have discussed the same thing in a Boolean instruction. That's why they didn't specify it here. That's it. Are you clear, ma'am? Have you all understand? Any doubt in this, ma'am? Any doubt? Listen, one more thing. Supriya. Supriya, Neetu Priya.
Yes, ma'am.
Okay. Here I have used 4 types of move X. X means what? Move X means what? X denotes what? I have to access which memory? While we have studied move instruction, did you remember or not?
Yes, ma'am.
Yeah. Move X means it will access. I have given in a figure, man. Move X means it will access the external.
External memory.
External which memory?
RAM.
Memory. Move C means what?
Ma'am. Hello.
Move C means what, ma? Move C. Move C means what? It will access which memory? You have forgot. Move C means it will access the program memory, code memory. I have told you. Remember, people, it's one of the important diagram. Which instruction is access the from external memory and external ROM memory in the data transfer instruction. So move X means it will access the external RAM memory. Move C means it will access the external ROM memory. So ROM memory, we all know 64 KB ROM is in externally, or else 4 KB ROM in internal. So whether it may access internal ROM or external ROM. But X means what? External RAM only. So people remember this diagram. It's a very important diagram. Which instructions are used. I think tomorrow I'm having the first hour. So all the 5 types instructions, arithmetic, logical, Boolean, data transfer, branching. So next part is we are going to see only programming. So these 5 instructions are there. So today you people kindly visit the LMS. I just upload. I have already put the unit 2 PPT. Once again, what is and all I have done small modifications. I will upload it. Kindly go through it. And tomorrow the question sessions will be there. Are you clear, ma? Now please answer your attendance.